Our problem here wants us to find the equation of a streamline passing through some point A, and then the equation of the surface where the absolute value, or the magnitude rather, is some value. So let's start with the first one. We want to find a streamline. Generally, the way you find streamlines is you relate. Let me zoom out a little bit. That's better. You want to relate the derivative to the y component over the x component of the electric field. Oops, sorry, did it again. We just plug in our x component and our y component, and just be careful here because you see the x variables in the y direction, the y variables in the x direction. Problems like these, I always screw up. It's so easy to mess up the variables in a problem like this, at least for me. We quickly see that the 400s are going to cancel, so we are left with dy x equals x over y. Solve this by separation. Y dy equals x dx. Integrate both sides. Y squared over 2 is going to be equal to x squared over 2. And we have a constant of integration. Now, we can eliminate these 2's because if we multiply everything by 2, we get y squared equals x squared. And this would be 2c, but 2c is really just another form of c. It's really just, it's always the same. It's a constant of integration, so it doesn't really matter if your value is scaled by 2, because it kind of works out in the end. Because if you had a 2 there, the value you would get would be twice as, half as big, rather. Anyway, we now plug in our y and our x values, which are 2 and 1. I'm getting that from here. So I'll just plug in a, which is 2, 1, and I believe there was a 2 here. Negative 2, whatever. That z really doesn't matter anyway. So we have 2 for the x, 1 for the y, so this will be a 1 squared equals 2 squared plus c. 1 equals 4 plus c. c is equal to negative 3. Plug in the c for our original equation. Equals x squared minus 3. And the book has this equation, but it's a little changed, so I'll play a game and manipulate it as well. Add this 3 over, subtract the y over, so you're going to have 3 equals x squared minus y squared, and then divide the 3. I don't know if this is like a special format of some sort. I'm not really sure about that, but regardless, there it is. So that's part A. That's all you gotta do. So now it wants to find the equation on which E, the magnitude of E, is 800. So how do we solve a problem like this? Well, we know that our magnitude is going to be some sort of x component squared over the y component, right? Squared. So what we need to do is we need to plug in 800 for that, and then this will hopefully give us some sort of equation that will give us what we're looking for. So let's set that. So the magnitude of E is going to be equal to the square root of the x component of this E field, which is 400y squared. This whole thing is squared, plus 400x squared. This is the AY direction. Well, it doesn't really matter what direction, because So scalar. All right. So now we have our equation. This is going to be equal to 800 because this is what we're looking for. We're looking for the point, the equation at which it's 800 volts per meter. So square this. This is going to be 400 squared y squared plus 400 squared x squared. And we can pull out this 400. This will just be 400 because there's a square on each of them. And then it'll be the square root of x squared plus y squared. And dividing this, you'll get 2, right? Answer that in a second. You have x squared plus y squared. I gotta hurry up because I want to take this call. And then you would just square this rather, and then you would have 4 equal to x squared plus y squared. And that would give you the equation that sets this equal to there. Because if you plug this into here, you would get 800. So there you go. Hope that helps. Bye.